Kia ora, Year 9. This video is going to go through the relational questions from the JAF practice for geometry. So this is a request from Kafua who wants to know what it means to give reasons in geometry. And what it's all about is that when we write down an answer to an angle, we're usually using one of the rules that we've got for angle reasons. So the most common ones are these. Now I'm going to write the shorthand out first, but you can just write the whole sentence. So the first and the most common one is angles in a triangle add up to 180 degrees. We write it like this because it's easier than writing out the angles in a triangle add up to 180 degrees. So I've tried to teach you the short ways to write these because we often need to use quite a few of them. But it's absolutely fine if instead you just write out the whole sentence. That shows really good understanding. So when we say give a reason, we mean write down next to your number, write down how you know that that number is the correct one. Or you can write out the sentence. Okay. So what I'm going to do here is go through questions 6 to 11 from the practice because they give us tons of practice at showing our reasoning. So let's look at this first question, question 6. So we've got angle G here. We've got an isosceles triangle because I've got these two marks. So in an isosceles triangle, we know that this angle will be the same as this one. So we can write down that 64 degrees plus 2G is equal to 180 degrees. So we're using two reasons here. The first reason is that the base angles in an isos triangle are equal. And the second reason is that angles in a triangle add up to 180 degrees. So we're not finished yet because we have to give the value for G. So 64 plus something is 180. That means that 2G must be equal to 116 degrees. Okay, and then 1G must be half of that. So G will be 58 degrees. Alright, so we've written our first statement, then we've given our two reasons, and we've given our final answer. Let's look at question 7. So there are a couple of ways to do this one. I'm going to do it a slightly less efficient way first, and that's using the angle in a triangle rule. And I'm going to put an extra angle in here and call it angle J. So we can say that J plus this one and this one have to add up to 180 degrees. So we write down our reason. Angles in a triangle equal 180 degrees. And I need to write, I wonder if I can move that over. Let's just see if I can move that down. Oh, there we are. So I have to write that this is equal to 180 degrees. And then I give my reason. So that means that J plus 124 is 180. So angle J must be 56 degrees. Next, I'm going to use the rule about the angles on a straight line. So now we can say that 56 degrees plus H must equal 180. And my reason is that angles on a line equal 180. So H equals 124 degrees. So that's that one done. Now there's a faster way to do this with one rule and one reason. So let's go back to the start. And this way goes straight to working out H. So one of the things that we worked out in class from those two reasons is that this angle here must equal the sum of these two. Right? And we saw why that is. It's because we just used the angles in a triangle reason and then the angles on a line reason. So we can put those two together. And we can say straight away that H must equal 50 degrees plus 74 degrees, which is 124 degrees. And the reason is that exterior angles, the exterior angle, there's only one of them, so the exterior angle equals the sum of the interior opposite angles. That's question 7 done. 2 different ways to do that question. Question 8, and there are quite a few different ways to do this one. I'm just going to show you one of them, or we'll be here all night. So here we've got parallel lines, and it can help sometimes if you don't see them, just extend them out, and then you'll see them much more easily, and you'll also see the transversal line going through. So if we draw those on, we're looking for angle I, but we can write on some extra angles. So I'm going to write on angle J in here. And we know that angle J must be 64 degrees because corresponding angles around parallel lines are equal. So that's what I mean by giving my angle reason for J. Now I know that these 3 in the triangle have to add up to 180. So 64 plus 53 plus I equals 180 degrees. That gives me 117 plus I is 180. I must equal, what's left over, let's see, 50, let's see, can I do any maths? Yep, there we are, 63 degrees, because the angles in a triangle equal 180 degrees. On to question 9. Alright, we've got more parallel lines. I'm going to grab that ruler and just draw my lines out. Now, you don't have to do this, but if you're me, it just helps you see where the line's going. So that's parallel there. And we could draw this one a bit more. Sorry about the background noise, it's music practice time here. Let's have a look at what we've got. Okay, so we can see we've got a triangle, right? So we've got a triangle, which is triangle BCD. We can mark in this missing angle here, and I'm going to call that angle A. So A plus 75 degrees plus 40 degrees adds up to 180 because the angles in a triangle equal 180 degrees. Okay, so that's my reason. That hasn't told me what A is yet though. So A plus 115 is equal to 180. A is equal to 65 degrees. So far, so good. Let's see if yep, that works. Now, we don't need angle A, we need angle P. But we've got parallel lines. So, P plus, oops, what's happening there? P plus, stupid computer, what's it doing? P plus A has to equal 180. And the reason for that is that angles, co-interior angles, parallel lines, add up to 180 degrees. So that's my reason for that. And now we're going to work out what P must be. So remember, A is 65. So P plus 65 degrees is 180. And P equals 115 degrees. So there, that's that one. Right, so look, we're giving those reasons every time we use them. So every time they're in our brain, we write them down. Number 10. Right, we can see an isosceles triangle, and we can see angle Q, and we might write in some extra stuff. So we know that angle, I'm going to do this one using angle letter names. Angle DBC must equal angle DCB because base angles in an isos triangle are equal. So what can I say about this angle and this one? Well, 68 degrees plus, and I'm going to call this one angle A, and so this one will be angle A, plus 2 lots of angle A is equal to 180 degrees. And that's because angles in a triangle equal 180 degrees. That means that 68 plus something is 180, so 2A is equal to 112 degrees. So one lot of A is half of that, 56 degrees. But we don't want A. We want this angle here, which is Q. So Q plus 56 degrees equals 180. My reason for that, I'll put the box down first, is angles on a line equal 180 degrees. So we have to find Q. So Q is 124 degrees. Got one left to go. With that violin playing downstairs, that's probably a good thing. Right, here we go. This one's got parallel lines and it's got a big triangle. So let's see what we get first. Well, lots of ways to go here. I'm going to find this angle here, then I'm going to find this one here, and then I'm going to find this one here at last. I'm going to put on extra letters. So this one here I'm going to make into angle A. This one here I'm going to make angle B, and then this one here is X. We know that A plus 107 adds up to 180 degrees. How do I know it? Because angles, co-interior angles, parallel lines, add to 180 degrees. So what's angle A? Well, angle A must be 73 degrees. Okay. Now, angle B is really easy because they're vertically opposite. So B is equal to 73 degrees. Vert, op, angles are equal. What's left? X. And for X, we're going to use the angles in a triangle. 27 plus 73 plus X is equal to 180 degrees. Okay, I can hear heaps of violin coming down the video now, guys. I'm sorry, but there are 4 people living in this house, and I can't ask them to be quiet. Right, so there we go. That's my next one, and that is my reason for it. So we're not finished, because we have to find out what X is. So we've got 100 plus a number is equal to 180. So X is 80 degrees, and we're finished. Right, so ka forward. Just notice that every time I give a number, I'm giving a reason. So that's all of those, and I'm going to do the unistructural as well, so that you can just see really simple examples of giving reasons. These ones are ones where we're linking up quite a few different ones. Very long video, sorry about that. One more coming up tonight to help you out with your revision. Thanks for watching.